All right, welcome. In this video, we're going to be talking about polynomial functions. And now in this class, we've already talked a little bit about linear and quadratic equations, like these right here. And, in the first unit and also in Algebra 1, you learned about, solving for x by, doing the same thing to both sides of the equation. So we, acted 8 divided by 7, and, that was fun enough. But then we bumped it up to quadratic, which is degree 2, because I'm seeing an exponent of 2 on one of my x's. And we saw that for these, the vast majority of them, we needed to set them equal to 0 in order to solve. So we would start solving this, like that. And then we would look at it and say, okay, maybe I can factor this, right? If I can think of two numbers that multiplied to -2 while adding to -1, now I was going to be able to factor this. And I can think of two numbers that multiply to -2 and add to -1. Okay, that's -2 and +1. Okay, and so we could factor like that, and then we would use the zero product property and say, okay, well, if two things multiply together to equal 0, one of them has to be equal to 0. So either x minus 2 is equal to 0 or x plus 1 is equal to 0, and that gives us our solutions x equals 2 and x equals -1. Okay. I think one thing I want to point out here is that if we have quadratic, okay, which is when we have degree 2, we should be expecting two solutions. And back when we had, linear, 1 power, okay, just x to the first, we're only going to have one solution. Okay. In this video, we're going to be talking about degree 3 and 4 and maybe even a little bit of degree 5 polynomials. And so we should expect those to have 3, 4, or maybe even 5 solutions. Then the next thing we learned was like, well, what if we can't think of two numbers that multiply to, in this case, -7 while adding to -1? What do we do then? And then we realized that, the quadratic equations, they were in general solvable by using complete the square. And we could use the quadratic formula, which is really just a fast version of completing the square. And so we saw that we could always solve for a quadratic equation that was set equal to 0 using the quadratic formula, which was x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay. And, I could simplify that a little bit. I could get 1 plus or minus the square root of 29 all divided by 2. Okay. So for polynomial equations, which are going to basically have an exponent of 3 or higher involved, we're going to need to learn how to solve these. So there is a cubic formula, right? It's just like the quadratic formula, except it's more difficult to remember. In fact, it's impossible to remember, I would say. This is one of the 3 solutions. Okay, so you've got this for ax to the 3 plus bx to the 2 plus cx plus d equals 0. Okay, this is going to be one of the equations in terms of a, b, c, and d. Okay, but you can look at this and see this is not good. This is not realistic, probably. Okay, there's also a quartic equation. Okay, based on what I just read in the past few days, the quartic equation was discovered first around 1540 in Italy, and then the cubic formula was published for the first time in like 1545, also in Italy, which you should pause this video and go search google.com for the quartic equation and look on images and just see how that's like. I can't imagine them discovering this at all, much less before the cubic formula. These are not going to be feasible for us to use in our class, right? So we can occasionally solve them directly, and we'll do that here in a second. But for the most part, the only way that we're going to be able to solve these higher degree equations is by factoring, okay? And then it also turns out that there is no formula for 5th degree or higher. It's not like there is out there and we just haven't figured it out yet. It's impossible, and that was proved by, around 1800, right? Sometime in the 19th century. Evariste Galois and people like that. And the nature of that's kind of what you would study if you studied mathematics at the college level. All right, now here are 3 that we aren't going to need to solve by factoring. We can solve them directly. And these actually have most in common with that linear equation I solved at the beginning, that 7x plus 8 equals 9. If all we have is just one expression in x and it's a power, we can probably solve directly like I'm about to show you. So over here, x squared equals 4, well, we could, probably take the square root of both sides. Okay, the square root of 4 is 2. The square root of x squared is the absolute value of x. And then, okay, if the absolute value of x is 2, then x is either equal to 2 or it's equal to -2. Okay. X to the 3 plus 1 equals 0. Okay, well, if I'm going to solve for x directly, then I'm going to subtract 1 from both sides and then take the cube root of both sides. Now, the fact that the cube root of x to the 3 is just x, whereas the square root of x squared is the absolute value of x, that's a little subtle, and I'm not going to really get into that in this video. That's something we'll talk about later on in the course when we talk about inverse functions. But for now, I'm just going to ask you to take that from me on faith, that this is going to be just x equals the cube root of -1. Okay? And the cube root of -1, you might be thinking that, okay, that's bad news, but it's okay. Think about it. Is there a number that I can take to the third power and get -1? And there is. I can take a -1 to the third power and get -1, so I'm just going to, okay, x equals -1. Okay. And then over here, when I'm going to start trying to get at x to the 4, so I'm going to subtract 2, divide by 3. And you may not have much experience taking fourth roots at this point in your math life. Okay, I don't know that I have a whole lot of experience taking a lot of fourth roots, but if you don't, take a step back, look at it, solve it with your eyes. Think to yourself, what's a number that I can take to the fourth power and get 16? And 2 to the 4 is 16. Then think to yourself, are there any other values of x that I could take to the fourth power and get 16? And I feel like -2 to the fourth should also be 16. Okay, so that's a way that we could solve directly. But the vast majority of the equations that you're going to be tasked with solving in this class that are, of higher degree, you're going to be solving by factoring. It's like really most of them are going to be solved like that. And so I'm going to kind of just copy in the first couple of. Okay, so I'm going to do the one on the left, and then you can practice on the one on the right on your own and check your work against mine. So I'm going to go in here, and I'm going to say, I'm going to look for, if I'm factoring, I'm going to start by looking for a greatest common factor. That was always our first step. And I'm seeing x in all three terms, so I'm going to factor out that x, and I'll be left with an x squared plus 5x plus 6. That's still equal to 0. Because I'm interested in using the zero product property again, right? Because it's true, no matter how many numbers you're multiplying together, if you're multiplying things together and you're getting 0, it's because one of those things is 0. So I'm going to keep going, and I can keep factoring x to the 2 plus 5x plus 6. That's x plus 3 times x plus 2. That's still equal to 0. And so one of these three things has to be equal to 0. So I'm going to say either x is 0, or maybe x plus 3 is 0, or maybe x plus 2 is 0. Okay, and so that would be x equaling 0, -3, or possibly -2. Okay. That's how we solve by factoring. Very similar to how we solved quadratics by factoring, right? Factor, zero product property, solutions. Okay. So why don't you try this one on your own? You're going to need to pause the video and work this one with it paused, because I'm just going to flash up the answers here in about 5 seconds. All right, there you go. So I started by factoring out the greatest common factor. I found that 2x, and then I was left with x squared minus 1, and that's further factorable, so I decided to take it all the way. Now, a person could, if they wanted to, kind of like go out here and be like, okay, I can solve that one directly, so I wouldn't need to factor. You could say, okay, x squared equals 1, x is plus or minus 1. But, I figured this is solved by factoring, so I'd factor all the way. All right. Let's do it again. So these are a little different because they're not set equal to 0. Okay, you can see they're pretty close. It's not going to be that hard to set them equal to 0, but it's going to have that first step added. So I'm going to come over here, and I'm going to start by setting this equation to 0. So x to the 3 plus 8x squared minus x minus 8 equals 0. Okay, if you're working on my notes book, there is a typo on this one. It said 80 instead of 8, but you want to scratch that out and make 8. Otherwise, it's not going to be factorable, and you're not going to be able to solve it by factoring. So what we're going to do here is we're going to do group and factor, because I've got 4 terms, and I'm seeing that ratio of 1 to 8 being the same as the ratio of -1 to -8. So I'm going to take the first 2 terms. I'm going to say, what can I factor out of them? X squared. And then the second 2, -x, -8. That's not a whole lot in common besides being negative, so maybe I factor out a -1. I'm left with an x plus 8, and that's a good sign, right? Because I can factor out that x plus 8 and be left with an x squared minus 1 again. Okay, so x plus 8 times x plus 1 times x minus 1 equals 0. So one of these factors has to be equal to 0. And, I don't think I'm going to write it out this time because I think y'all have gone far enough that you can see that if x plus 8 is a factor, x equals negative 8 is going to be a root or a solution of this equation. Okay. And there I got myself 3 solutions for a third degree equation. Okay. Now I think you should try your luck on the one on the right. That one's got a little bit something different going on. So try it, see how it goes, and check your working against mine, which is going to pop up in 5 seconds. All right, there you go. So I factored it down the same way using group and factor, but then I wasn't able to split that other thing into a difference of 2 squares because x squared plus 3 is not a difference of anything. It's not a difference of 2 squares for sure. So I wasn't really able to do anything with it. So we could set it equal to 0 and just see if we can solve it, but that would cause me to be taking the square root of a negative number, and that's not a real number, and so it's not a solution, okay? Because we're only talking about real number solutions in this unit. So I got just the one solution. Now, you would expect a third degree equation to have 3 solutions. And what we'll see later on in this course is that we will actually have 3 solutions here. There's just 2 that are hidden that we can't quite see, that are hidden behind that x squared plus 3 equals 0. So I think that's all I'm going to say about that for now. All right, now let's solve some 4th degree equations. Okay. Here was another typo on my notes book. If you're looking at it, it didn't say it equaled anything on that equation on the left. You just want to say it equals 0. Okay, so x to the 4 minus 5x to the 2 plus 4 equals 0. We factored this object quite a bit in the last unit, so I don't think it would be surprising to you if I factored this with x squared plus some number times x squared times some other number. Okay? So I'm looking for 2 numbers that multiply to positive 4 while adding to negative 5, and that's going to be negative 4 and negative 1. So I'm going to just put those in there like that. I think I oftentimes said let t equal x squared when I was just showing you how to factor this, but we did this a lot in the previous unit. So and that's why we did it, was because I wanted to be able to factor some 4th degree things and then eventually sketch their graphs. So that's what we're doing here. Okay, this can factor more. I don't know. I'm going to end up with 4 factors here. So I'll have x plus 2, x minus 2 times x plus 1 times x minus 1. That all producing 0. Okay, and then I'm going to say, okay, well, either one of these things has to be equal to 0. So either x is equal to negative 2, x is equal to positive 2, x is equal to negative 1, or maybe x is equal to positive 1. Okay? And that's how we solve a 4th degree equation. Okay, so why don't you try the next one on your own? This one's got a little bit more to it, but explore on your own and see what you can come up with. I'm going to flash in the answers here in like 5 seconds. All right, there you go. That's how I'm going to solve this equation, right? If I get it down and I'm like, oh, I can directly solve x to the 3 plus 8, and take the cube root of negative 8 and get negative 2, that'd be good. But maybe you solve this differently, right? Because you just learned about the sum of 2 cubes. So I'm going to bring in the work that would go with that. So you got maybe about that far, right? And so you got the same 0 and negative 2 that I got, but with this one, you would have to go in and use the quadratic formula because that second factor, when you're doing a sum of 2 cubes, it's never factorable itself. So you would do, and this is part of the reason why, when you do the quadratic formula, it's not going to come back with a real number. So x equals negative b plus or minus the square root of b squared minus 4ac is 16. Okay, that's taking the square root of a negative number, all divided by 2a. This is not a real number, so we are going to be not considering it right now. But maybe later on in the